So students, previously we have discussed about the extraction of metal, that is metallurgy. We have already dealt about the two steps that is involved in the metallurgical processes. First is grinding and crushing of ore, and second is concentration and enrichment of ore. Now we are going to deal with our third step. The third step is basically the step that is involved extraction of metal from its ore. Now metal can be extracted from its ore by two methods, that is called calcination and roasting, and these two methods are different for different type of ores. And lastly we are going to deal with the purification step, that is called the refining of the metal after obtaining from ore. So we are dealing with the third step, that is extraction of ore, extraction of metal from its ore. So our third step is basically, the third step is extraction of metal from ore. So extraction of the metal from ore is easily done by using the reduction technique. It can be done using the reduction technique, and we have basically two methods for the extraction of the metal from the ore, and these two methods are simply, one is calcination and the second method we have is roasting. Now these are the two different methods used for extraction of the metal, but the difference between these two methods is that this method is done in the absence of air, and this method is basically done in the presence of air. So this is the brief criteria about the calcination and roasting. One more thing about the calcination and the roasting process is that calcination is usually done for the carbonate ores and roasting is usually done for the ores that are simply sulfide ores. So we can say that calcination is done for carbonate ores and roasting is usually done for sulfide ores. So this is all about the calcination and the roasting method we have discussed here. Now what actually happens in case of calcination, we are converting the ore into the carbonate ore, and that carbonate ore is reacting with oxygen to give the simple metal. And in this method, firstly metals are converted into the carbonate ore. After that carbonate ore, water is removed from it. It means moisture is completely removed, and the third step is that volatile impurities has been removed from the method. So what will happen here is, if I am talking about calcination, there are the three things that actually happens in case of the calcination. It is converted into oxide. Second step is water is removed, and the third step will be volatile impurities are removed. So we can say that these are the three basic criteria that are concerning to calcination. Now we are talking about the calcination, so we will understand the method of the calcination with the help of an example. Suppose I am taking the example of calamine, that is called zinc calamine, ZnCO3. It is usually calamine. Now what we are doing here, we are performing calcination. We are doing calcination of zinc carbonate. And what we are going to receive here, zinc carbonate has been reduced to ZnO plus CO2. It means we are getting zinc oxide. It means carbonate ores are converted into the metal oxide. So here we are getting ZnO in this step. Now we are considering the another example. First example we have considered the calamine. Second example we are talking about the ferrous carbonate, that is FeCO3. FeCO3 after performing calcination this is actually siderite. This after calcination will going to give FeO plus CO2. Again we are seeing here that siderite has been reduced to FeO, that is after carbonate we are receiving the oxide. So this is a basic method of calcination. Firstly we are getting oxide, then this oxide has been reduced by using the suitable agent and the metal is obtained in this process. And this process is basically done in the absence of air. So we can say that this process is actually the calcination process. So this process is actually happening in the absence of air. Now we are going to discuss about our next method. Our next method is roasting. Roasting is usually done in the presence of air and it is basically used to extract the metal from sulfide ores. So in the side we are taking the sulfide ores in the presence of the oxygen to get the particular oxide. So before starting roasting, if you want to copy it from here, please copy it now. So our second step is roasting. So for the roasting, we have a basic example, that is we are taking the sulfide ore and perform its oxidation in the presence of air only. So what will happen here? We are taking ZnS. ZnS is zinc blende. In the presence of air, that is 3O2, roasting is performed. So we are doing roasting here, and what we will get in the product side, we will get ZnO2, ZnO plus SO2. So the products are ZnO plus SO2. So you can see here the sulfide ore is initially converted into oxide in the process of roasting. So we are getting zinc oxide this side. Now we are taking another example for this, that is FeS2. FeS2, 4 FeS2 going to react with 11 O2. We are again performing the operation of roasting, and after roasting, this sulfide is going to convert into the oxide, and oxide is further reduced to get the particular metal. And what I am getting in the product side, I am getting Fe2O3 plus SO2. On balancing the equation, we will get the complete equation here. So these are the basic steps of roasting that is present and that is done only in the presence of oxygen. These are done in the presence of oxygen. So extraction of metal is usually done into the two steps. Firstly, converted that ore into oxide, and after reducing that oxide into the particular metal. But the ore is oxidized or reduced into the particular metal not only by the simpler means, it will depend upon the reactivity of the metal. So we are going to discuss about the different methods how ore are converted into the particular type of the metal. So our next step is this will be our next step. Now, the two steps in the process of extraction of metal are firstly, ore is converted into oxide, and in the second step what we are going to do, in step number 2, that oxide is getting reduced to get metal. In this step we are performing calcination and roasting, and in this step we are performing the next reaction, that is called reduction. So firstly, ore is converted into oxide, then oxide is getting converted into metal. In the first step we have performed calcination and roasting, now we are performing the reduction technique. But the reduction technique usually depends upon the reactivity of the metal, and it will be different for different metals. Metals of high reactivity will show the different scenario, and the metals of low and medium reactivity will have a different kind of reaction. So here is a flow chart that is explaining about the extraction of metal. Suppose I am considering about the metal of high reactivity. In case of metal of high reactivity, what we will do? We will do the electrolysis of the molten ore. It means reduction cannot be done by using carbon monoxide and aluminum alone. In this method, we are using electrolysis of molten ore to get the pure metal. Now, we are considering the metals of medium reactivity. In medium reactivity, again we have two categories. One is carbonate ore and second one is sulfide ore. As I have already told you, for carbonate ore, we are going to perform calcination, and for the sulfide ore, we are going to present the roasting. Now, this metal oxide has been converted into the metal by reduction by carbon, reduction by aluminum, and sometimes reduction by carbon monoxide has been usually done. So this is about the medium reactivity elements. Now is very simple, but for high reactivity and medium reactivity, we have to perform the different functions for getting the ore, for getting the metal from their particular ore. So I hope this flow chart has been clear to you that how will the reactions has been carried out in a particular process. So now we are going to move . This means metallurgy or the minerals are actually the natural occurring substance that is found in the earth crust. If I am considering the ore of sodium is basically the rock salt. If I am considering about the ore of aluminium will be the bauxite ore. If I am talking about the ore of zinc, I have already discussed calamine. Calamine means zinc carbonate ZnCO3. You have usually heard about the advertisement that is coming in the form of the advertisement in the TV about the lactocalamine solution. So it is somewhat that calamine we have used here. Next is copper. The ore for copper is the cuprite. It is usually a sulfide ore. Now, so before this, we have to see a reactivity series of the metals, that how metals show reactivity. So you can easily see from here that potassium, sodium, calcium, magnesium and aluminium, these 5 metals are showing very high reactivity. So we can say that these are the most reactive metals. So which are the most reactive metals? Potassium, sodium, calcium, magnesium and aluminium. Now you see chart, we have zinc, iron, lead, hydrogen and copper. These 5 elements are considered in the metals with medium reactivity. It means we can say that these are the medium reactivity parts, and the reactivity will going to decrease from topmost part to the lower part, as we have already discussed about this topic in the reactivity series. So we can say that reactivity decreases, and the medium reactivity elements are, we have zinc, iron, lead. So you can see here the reactivity elements are zinc, iron, lead, hydrogen and copper. So these will show the reactivity in the middle part of the section. Now we can see that metals with very high reactivity are, very least reactivity are mercury, silver and gold. It means they are the very less reactive metal because reactivity decreases from top to bottom in this table. So the less reactive metals are mercury, silver and gold. So this is all about the reactivity of the elements we have shown here. Now we will see how will we obtain the metal from their extracted ore for all these type of the compounds.